Would you mind repeating again?
Legend.
I got 120x cubed all over ln of 7 into open bracket 6x to the power of 4 plus 3 close brackets.
Makwena, beautiful.
Okay. Up to so far, Makwena, Theo seems to be in agreement with what you said. Please talk to the others, whether they agree with you or not.
Okay, family, how are you? Do you guys agree with my answer?
Be good, and yeah, Kansila agrees with your answer.
Thank you. Anyone else who disagree?
Yeah, myself, I just did it now, but I managed to find the same answer as yours.
Who's talking? Who did it now? Malus.
Yes, sir.
Okay, thank you, Malus. Ishmael, Erica, what are you supposed to say?
Sir, can you repeat the answer again?
Okay.
I got 120x cubed divided by ln of 7 multiplied by 6x to the power of 4 plus 3.
Okay, I say I agree.
Yeah. I agree as well.
Yes, Lerato got the same answer as well. He agrees. I'm reading his solution right now. I'm speaking on his behalf. He agrees.
Oh, okay. Thank you. Let me thank everybody for having attempted number 14. Now, is there any volunteer?
I got 2 to the power of x in ln2, times ln7 to the power of x squared minus 4 over ln3 plus 2 to the power of x plus 1 times x ln7 over n3 ln3-ish. That's what I got. Let's not make sure.
Okay. Please.
Yeah.
Let me ask you to repeat. Members, please listen to the answer that Sharon is sharing with us. Sharon, please repeat.
Oh, okay. I got 2 to the power of x ln squared. No, it's not squared. ln2 times ln 7 to the power of x squared minus 4 over ln3 plus 2 to the power of x plus 1 times x ln7 over ln3. That's what I got.
Please talk to them whether they agree with your answer or not.
Sir, I got a different answer.
Who got a different answer? Is it Magwena?
Yes.
Thank you, Magwena. Okay, up to so far, Magwena disagrees with you, Sharon. Who else agrees or disagrees with Sharon?
I agree with Sharon.
Oh.
Yes, Sbusiso agrees with Sharon. Okay.
Yes. Yes, Lerat.
Did you pass that step?
Lerato, we don't hear you.
It isn't good on my side. The network is fine. Okay,
yeah, you are better now.
The picture that I sent for Sharon to get a step, does she pass it or what? Because I don't know what's happening here.
Now, Sharon just simplified the log 3 bracket 7 to the exponent of x squared minus 4 to just ln of 7 to the exponent of x squared minus 4 all over the ln of 3. Then after simplifying that she did, she used the product rule and simplified everything.
Yeah, I did that.
And see product rule, like Let's leave it, man.
Okay, this is where I started. Let me just send it.
What's wrong, Lerato? Are you okay?
Say I'm fine. The
He
product rule,
didn't see the product rules.
I use product rule on my wiki. The thing
I
is,
also used it as well. That's why I sent it via
what I'm asking
the
is,
chat.
the answer
Okay.
I sent is not fully simplified. That's why I'm asking.
Oh, I simplified it at the end.
So I want someone to tell me that you passed the step because I just left it the way it is without
Lerato, please repeat your concern.
like I saw the product rule and
You saw the product rule.
and then I did it different from Sharon. So I want to know because Sharon changed her like the right side or G of X in to lean 7 x squared minus 3 minus 4 all over lean 3. On my case, I separated 1 over lean 3 times over 7 to the power x squared minus 4.
Is your answer different from what she got?
That's what I'm asking. Or does she pass the step that I
No.
did to get the answer? That's what I'm asking.
I didn't pass the step. I first opened was this log 3 base 3 7 x squared minus 4. I opened it before I started the product. Was this rule?
It's fine then.
Okay.
Are you sure, Lerato?
Yeah, now I can see my answer is different. The one that I got. That's awesome.
Then what is your conclusion? Are you saying what Sharon found is not what she was supposed to find, or
I'm
you
saying
yourself?
I'm saying what she found and what I found, friend. Which one is correct? No one convinced me which one is correct. They are different. That's what I'm saying. Because Busiso said she agrees with Sharon. Makuna said different answer. I said
disagree.
Erika did not say anything. Tio did not say anything.
I disagree.
Okay.
Okay. Okay. Hang on, Lerato.
Disagree with what?
Okay. Hang on, guys. Please. Okay, please. Sharon, please repeat your answer, then I will guide the discussion.
Oh,
Please,
I got.
Oh, okay. Please, hang on, Sharon. Please, may I request all of you to listen attentively for the last time, Sharon.
Okay.
I got 2 to the power of x ln 2 times ln 7 to the power of x squared minus 4 over ln 3 plus 2 to the power of x plus 1 times x ln 7 over ln 3.
Thank you. I hope you all captured what Sharon said. Now, here is my question. Who agrees with Sharon? Sbusiso and Sharon are in the same crawl. Who disagrees with Sharon and Sbusiso?
Theo.
Okay.
So my answer is similar to Sharon's answer.
Okay,
I just didn't change the log into the lin.
Oh yeah, that's the same
that she did.
Yes, me too. Me too.
Okay. Okay, Makwena,
Now Theo agrees.
No, the only thing I disagreed was I also didn't change the log into the
Hello.
But it's still the same answer.
Yes, everything else I agree with. It was just that part. So I just needed to. I just need to be
I
schooled.
trusted you,
So. I don't know. So please school me and make me understand.
Okay, guys.
Bro, you're the one who taught me the lead.
Laugh with me, right?
Okay, those who disagree with Sharon, Sbusiso, and Erika are Makwena, Lerado, who else? Makwena and Lerado are disagreeing. Can I conclude that the rest of you who are just silent are in agreement?
And
With
Homo is
Sbusiso?
here. You can record Homo. Homo is here and obvious.
Thank you, Homo, and obvious. Okay.
Yes.
All right. Welcome, obvious. Welcome, Homo.
Yes, how are you, sir? How are you, everyone? I'm back.
Good.
You.
People, what is the ruling? Sbusiso, Sharon, and Erika agree on the answer that Sharon shared with us. Makwena and Lerado, you are disagreeing. Okay, let me start with Makwena. Makwena, what did you get?
Okay, I got 2 to the power of x, ln of 2, multiplied by log base 3, into 7 to the power of x squared minus 4 plus 2 to the power of x multiplied by 2x ln 7 over ln 3.
Lerado? Thank you, Makwena. Lerado, what did you get?
Sir, I got 2, big bracket, log 3, small bracket, 7 to the power x squared minus 4, close small bracket, close big bracket, plus 2x times 1 over ln 3 times 1 over 7x squared minus 4 times ln 7 times 7x squared minus 4 times 2x.
Is your answer similar to Makwena's answer?
I don't
Or is
know,
it
sir.
different?
I don't know.
Makwena, Lerado, please listen attentively. Makwena, please repeat your answer.
Okay, my answer is 2 to the power of x ln 2 times log base 3 and to 7x squared minus 4 plus 2 to the power of x multiplied by 2x ln 7 over ln 3.
Lerado.
Oh, I think I made a mistake. Yeah, I made a big mistake on this question when I copied it down.
Okay.
2 to the power of x, not 2x.
Oh. Then, Makwena.
I did Makwena, sir. If it's 2 to the power of x.
All right. Makwena, then where do you differ with Sharon's Sbusiso and Erika?
I didn't change the log.
You didn't change the log.
Yeah, that's me too. Everything else is perfect. Well, looks like mine.
I changed mine because I get confused, so my bad.
Oh, okay, no, it's fine. But again, I'm glad you did, because if
I
you
also
hadn't,
didn't change mine.
I wouldn't have learned this. So thank you for changing it, because I learned something new.
Okay.
Isn't it log equals to ln e only if it has base e? Isn't
So
it?
what? No, you know what? So what's happened here is she's applied the change of base formula, basically.
Oh.
And then by applying the change of base formula, it changes logs to natural logs. Yeah, that's what she did.
So, Sharon, Sbusiso, and Erika, is this what you got?
Yes, sir, but mine is different because I open it up. If I close it back, it's the same.
Okay. Makwena,
Sir?
is this similar to what you got?
Yes.
Yep, this is exactly what I got.
Exactly, sir. Exactly that. What you see there.
Exactly. This is what I got.
Okay.
So I also got the same answer.
Can I ask a question quickly?
Speaking?
Ishmael, sorry. It's Ishmael.
Did you also get the same answer, Ismail?
No, but I went down a rabbit hole. Is it not possible because you've got 2 to the power of x times log 3, 7 to the power of x minus 4? Can you not move the x minus 4 to the front and then make it open close brackets x minus 4 multiplied by? No, but that doesn't make sense. Could you do? Can you do that? Can you move the power to the front?
To the front.
Yeah, the x minus 4, instead of being a power, move it to the front so you have open bracket x squared minus 4 close bracket 2 to the power of x times log base 37. Can you do? Is that legal?
Why? Do you want to do that in this case?
Well, if you did that, then log base 37 becomes a constant. Then you don't have to differentiate it.
Yes.
But if I follow that approach, I don't think I end up with the same answer. But is that step legal, sir? Can I do that?
I just don't want to say yes or no, because I don't see you are working. Yes.
Okay. Can I answer the questions?
Okay.
He can't do that, sir, because right now we are given we are given a base, sir. So if he does that, it means he's redefining the function as a whole. So he can't do that, sir.
Okay.
Yeah.
Thank you. Now, can we step off this one?
Sorry, sir, can you just hold on there quickly? I just want to copy down the answer again quickly so I can go through it later again. Just 2 seconds.
Okay.
Ln 2 log 3 7 x squared minus 4 2x. Okay, I got it. Thank you.
Thank you. Now, hello.
With what we were saying about taking the power to before the log, I think it's gonna work, because I also tried to prove it on my calculator and it's working.
On your calculator, which you are not allowed to use.
Like, I was just trying to prove this other a rule of logarithms that says if I'm having log base a of b to the power c, then I can take c to multiply log b base a. That's what I was trying to confirm, and it works.
Okay.
Say, can I say something?
Allow me to stand on the fence on this one. Yes, Busiso.
If he does that, say, he won't find the equation where we have never mind, sir, never mind. I'm getting lost. Never mind.
I mind. This is why I mind.
Sir, sir, I got lost for a bit, sir. I'm sorry, sir.
Sir, if I can just add on top of what Busiso is saying, in my own opinion, if you do change that and you rewrite it in that form, you will now have 3 functions multiplying. And I'm not sure whether when you have 3 functions multiplying, what rule is there for 3 functions multiplying. So if there is, and you colleagues feel comfortable with it, then you can go ahead. But I would also stand with Sir's opinion in this, in terms of just stick to what we know so that we don't complicate the entire equation as a whole.
Thank you, Abdul.
No. It's not going to be 3. Okay. Oh, I was saying, say, it's not going to be 3 functions because the logarithm is going to be a constant in a way.
Okay.
Yes.
I'm lost in this whole discussion. So let me just keep quiet. I just don't like to respond to things that I'm not following them. Okay? I'm being
Yes.
fair. Yes. Now,
Yes.
let me take you back somewhere. But, is it necessary? You remember, okay, here we dealt with this. Remember this. Aha, do you still remember this? This is what we have been using, eh? Remember this definition?
Yes.
Is what we have been using, eh? Yes. Do you disagree?
I agree.
Okay. Do you still remember the application of this? Is what we have been using, eh?
Yes.
Mm-hmm. This is what we have been using as well, eh? These properties.
Yes.
Mm-hmm. Even this, eh?
Yes.
Mm-hmm. Yes. Even this is what we've been talking about, eh?
Yes.
Yes. Yes. Now, the reason I'm asking you this question is because I want to confirm something with you. Based on what on those few sections that I just went back, where you just said yes, 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 then are you sure that I want to skip this exercise, but do you promise me that you will be able to handle these kind of exercises? This is exercise 2.8E.2, where they're saying for the following exercises, use logarithmic differentiation to find the derivative of y with respect to x.
These things, the exponential function. Yes.
Okay.
Yes, sir.
All right. If you will be able to do that, then I'm happy. So now, let me now say to you, I'm now stepping off this section. Then I'm not going to go through these exercises since you will be able to handle them. Now let's go and visit our friends in another village. They are waiting for us. They're expecting us.
Yes, sir.
Yes.
You say there are no calculator allowed, but here I saw something saying using a calculator.
Lerato, of course you would see that.
Using the calculator to fit P equals PT squared. What? Fit line what?
Okay. Thank you, Lerato. May we please now talk about antiderivatives. We are not going to talk about rectilinear motion. Now, the reverse of, Lerato, please read this line that I've highlighted.
The reverse of differentiation.
Okay. Now, read the next below that starts with at this point. Please read this whole sentence.
At this point, we know how to find derivatives of various functions. We now ask the opposite question. Given the function f, how can we find the function of derivative? I think it's f prime, f, or how can we find the function of derivative f? Question mark. If we can find the function f derivative f, we call f an antiderivative of f.
For us, there is a definition of antiderivative there.
The function uppercase f is an antiderivative of the function lowercase f if prime of uppercase f equals lowercase f for all x in the domain of lowercase f.
Now, most important thing that you is this. That what? Antiderivative is the reverse of what?
Differentiation.
Is it clear to everybody?
Yes, sir.
I'm not only talking to Lerato.
Yes, sir.
Yes.
I'm
Yes,
talking
sir.
to everybody. I just needed Lerato to emphasize the situation that we are facing. Now, general form of antiderivative. Let capital F be an antiderivative of small f over an interval I. Then, number one, for each constant c, the function capital F of x plus c is also an antiderivative of small f over that interval. If capital G is an antiderivative of small f over the interval I, there is a constant c for which g of x is equal to f of x plus c over I. In other words, the most general form of the antiderivative of f over the interval I is f of x plus c. Now, is there any question on what I've just spoken to you about this antiderivative from where Lerato started reading up to this point?
No, sir.
No.
Shama question.
Is everybody clear on what I've spoken as antiderivative up to this point?
Yes.
Yes, sir.
Yes.
Okay, thank
Yes.
you. Now, Ishmael, please
Yes,
tell
sir.
us, what is, do you see number A?
Yes.
Of number
Number A is the answer to that is x cubed.
For them, Ishmael?
I said the answer to number A is x cubed, x to the power of 3.
I agree. X cubed plus c.
Oh, sorry,
I
plus
also
C. Sorry,
agree.
plus C.
Plus
Plus
C.
C. Yeah,
Plus
sorry,
C.
plus C. Yeah.
It's not the same.
Is with good grace.
We agree
On what?
on the answer.
What is the answer?
X cubed plus C.
What's the answer?
It's x cubed plus c.
What happens to the 3?
And yet, when you integrate 3x squared, it becomes 3x cubed over 3. And then the 3's cancel out, and then you're left with x cubed plus c.
It's 3x cubed dx.
Hello.
What you are anti-deriving? It's 3x cubed.
No, so Angiti, the function is 3x squared, right?
3x squared.
If the function is 3x squared and we are supposed to find the integral, then it becomes 3x squared or 3x to the power of 2 plus 1 divided by 2 plus 1, which is 3x cubed over 3. And then the 3's cancel out and you're left with x cubed plus c, right? And yet you add one to the power, then you divide by that result.
Like, we're not integrating, we're reversing the differentiation.
Nanti, what is reversing differentiation? Is reversing
Lerato,
differentiation
what
not
is
integration?
this?
It's not.
Lerado. What is this? Look at what I've highlighted. What is this? Read this.
Say, we're reversing the differentiation, which means we should take our steps backwards.
But actually, that is true because look at this. Look at it
It's
this way.
called
Once you
integration, Rato.
okay,
It's called
let me
integration.
Rato, tell me something. What's the derivative of x cubed?
It's 2x.
2x what?
X cubed.
What's the derivative of x cubed?
X cubed is 2
Yeah.
squared. Something like
Is
that.
that not what we have there with a?
It's 2x.
No, but Lerato, the derivative of no. Now you're playing games with me. No, stop it.
2x squared, man. 3x squared.
Yes, and then
Yes.
So now x cubed, 3x squared.
thank you. And 3x squared is what we have there by a, right?
I don't trust you.
Sir, can we move on, please?
Okay, thank you. Now, there was someone before I was interrupted by the network. Ishmael gave the answer. There was Lerato. There was a lady in between. I'm looking for that person.
That's dx.
Is it Homo or is it Kanye? Or is it Sharon?
I think it was Sharon.
I know it's not Makwena.
Sharon.
Sharon,
Yes, ma'am. Yes, sir.
was it you?
I said I
Thank
agree
you.
with Ishmael.
Oh, okay, thank you. Now, Sharon, in less than 30 seconds, please, what is the antiderivative of number B?
Oh, ln x.
Please ask if there is anyone who disagrees with you.
Is there anyone who disagrees with me?
Nope.
Nope.
You left the question C.
Plus C. Sorry, plus C.
Because of there's no C.
Sorry, plus C. Sorry.
Now I agree.
Now I agree.
Okay, thank you. Now, Homo,
Yes, sir.
how?
Sorry, I think my connection is quite bad. I didn't get that.
I hear you. Don't worry about the question. Okay.
So you're breaking up really badly.
Yeah, you're breaking up. I thought maybe it's me, but I think it's you, sir. You're breaking a bit.
Am I breaking?
Yes, sir.
Okay.
Hello. I don't know. Can you
think-
guys hear anything, or is it
I-
is he losing his connection?
Yes,
I think
he is.
Yeah, I think he just
is.
disconnected to reconnect.
Oh, okay. All right. Maybe he wanted me to answer number C. I don't know. So I'll just answer, and then we'll just catch him up when he's back.
I think I'm back now.
Yes, you are, sir. Welcome back.
Are you still able to see my screen?
No.
Okay, let me share again. Can you see the screen?
Yes.
Yes, sir.
Yes.
Yes, sir.
Thank you. How is the connection now? Is it much better or still the same?
Much better.
So much better.
Much better, sir. Much better. Thank you.
Okay, thank you. Now, Homo,
Yes, sir.
please, in less than 30 seconds, give me the antiderivative for number C.
It's sine x plus c, sir.
Please ask them who disagrees with you.
Who wants to fight? I'm kidding. Who disagrees with me?
I do.
I do.
I do.
Okay, thank you. Now
Can
I'm
you
going
repeat
to
your
confirm.
answer for me?
The answer is sine x plus c.
No, you're missing the negative.
Mm-hmm.
Yeah, I'm using the negative most likely.
Actually, she's right. The derivative of
She's
sine
right.
is
The negative.
cos.
Yes.
The
I
derivative
agree
of
with
cos
that.
is negative sine.
So
Oh,
if it was
yeah.
sine,
Yes,
then the
sorry,
negative was
sorry.
gonna be place.
Sorry, yeah.
Yes.
Oh,
Apologies.
We're not
yeah.
fighting, Homo. Don't worry.
I
They're
see
not
that
fighting.
you guys are not afraid of fighting, but
They are not
it's
fighting.
fine.
No.
All right,
Them.
all
They are
right,
not fighting. They
all
are not
right.
fighting.
Noted. Okay, cool.
So what is it, Romo?
I still maintain it's sine x plus c.
What about the negative?
It's not negative, sir.
Okay, those who are saying the negative,
Me.
They retracted their statement, sir.
Oh,
okay.
wait. Hey, like, cos it's not negative sine x.
I don't know. Talk
Because like
to, is it, yeah, that's Romo. Please talk to Romo.
because
That's what
like
we're looking.
they're confusing me now.
I think what's confusing is that if you're looking at it as the derivative of cos x is minus sine x, but here we're looking for the antiderivative. So the
Yes.
antiderivative of cos x will be sine x plus c.
Sir,
So I think
Hello?
the confusion with the negative is if your mind is still trying to find the derivative of this, that's where the negative will come through. Yeah.
Okay, Romo, you are saying it is positive, sine x plus
It is,
c. Okay,
yes,
thank you. I heard
positive.
that. I captured that, Romo. Vio, what are you saying?
so I was saying, if everybody's okay with it, can I just share something on the group quickly that just makes it easy to remember these things? Because the signs get confusing after a while, I think.
Okay.
Yeah. So something I
That
came
will
across.
help a great deal. Yes, that will
something
help.
I came across without looking for it, and it's perfect. Like you just never forget. So I'm posting it on the chat. If everybody can have a quick look, that it just makes sense. So you derive going down and you integrate going up. And the nice thing is it's a repeating function. So even if you integrate sine, as you know, integrating sine, the integral of sine is negative cos. So you just go from the top and you start right at the bottom. I think this fixes everything for everybody.
Okay, Theo, are you agreeing with what Romo said?
Yeah, 100%.
Okay, thank you. Now, Magwena.
Yes, sir.
How are you?
Good, thanks. How are you?
Magwena, you talk to Obvious, ne? There is someone by the name of Obvious here, ne?
Yes.
The two
Yes,
of
I'm
you,
here.
yes, the two of you talk to each other and tell us the antiderivative for number D.
Okay, the antiderivative for number
You
D
talk
will
to him.
be obvious. I'm
Yes,
saying is
yes, I'm listening.
e to the power of x plus c. Do you agree?
100% I agree with you, Makwena.
Okay, does the class agree? Family?
Yes.
We agree.
Agree.
Yes.
Okay, thank you. The first one. Here is the first one. Do you see the first one? Do you see where the cursor is?
Yes,
Here.
sir. Yes.
This is what I think it was Ishmael.
Oh, I can't see anything.
Here is the cursor. The cursor is dancing here. Do you see? Can't you see my screen?
I can see your screen, sir, but I can't see what you're talking about.
Do you see the last line?
Yes,
Do you
I
see
can
this?
see.
Read
Yes.
from here, from read. Read.
So where? I can see only the solution.
Magwena,
Yes.
do you see the last line? Do you see this last line? Do you see this last line?
Which last line? I see the example.
Sure.
Makwena, hey.
Can someone help out?
Do you see the bit that says 3.9.1 right at the bottom of the page?
Yes, example 3.9.1.
No, in the blue, in that little footer thing that's got, it just says 3.9.1, then it's got 3-5 2022. Sir's just above that line.
I can't see it.
Read the whole line, you will see it.
Makwena,
He's
read this
highlighting it
line.
now.
Do you see this line that I've highlighted?
Sir, I don't see what you've highlighted.
Makwena, do you wear spectacles?
Wait, sir. Maybe it's frozen on her side, so
Yeah.
maybe she should try disconnect and reconnect. Because what usually happens is when you lose connection, it just freezes.
Okay,
picture
Makwena,
freezes.
please.
All right.
Okay. We'll come back to you. Please let us know after rejoining. Ne? Makwena, maybe we should wait for a few seconds. Makwena, are you back?
About, say.
Makwena.
Now I can see what you're talking about. I didn't see this whole thing.
Ah, good.
Okay, thank you. Do you see the last line? The last line, this line that I've highlighted form?
Yes.
Yes. Now, this is what Ismail gave us as the answer that we're looking for. Okay.
Okay.
Now we are going to number B. Number B, we were given that the answer that we were looking for was this. This. Okay.
Yes.
We all agreed, ne?
Yes.
With ln of x plus c. That is what we all agreed on. Now, the next thing that we agreed about was this sine of x plus c.
Yes.
Okay? Sine of x plus c. The last thing that we agreed about was e to the power x plus c, which is this one. Okay?
Yes.
Now, everybody, do you see exercise 3.9.1?
Yes.
Yes, sir.
Please find the antiderivative of f of x, which is equals to sine x. I'm giving you 1 minute. Obvious, what did you get?
I got minus cos. I got minus cos x plus c.
Please talk to them.
Do you guys agree?
I agree.
Yep. Same.
Abdullah agrees.
Yes, I agree as
Who
well.
disagrees? Who disagrees? Okay, nobody disagrees. This is what we're looking for. Thank you, obvious. Now, let's talk about something interesting. Something that confuses Lerato. And yesterday I denied to be dragged into his confusion. Now, let's now talk about indefinite integrals. We are all familiar with this sign. Eh? Okay, let's look at this definition. Indefinite integrals. Given a function f, the indefinite integral of f denoted by the integral of f of x dx is the most general antiderivative of f. If capital F is an antiderivative of f, then the integral of f of x dx is equals to capital F of x plus c. Any confusion?
No, sir. We're all good.
Still with me?
Yes, sir.
Oh, thank you. Now, if we are all still good, now let's read. Yeah, you see this line that I've highlighted?
Yes, sir.
It says the expression f of x is called the integrand, and the variable x is the variable of integration. Now, that is all that I needed to say about this line. What is it that I need to say? Okay, now, please, let's come here to power rule of integrals. Do you see this? Power rule of integrals, this, what I've highlighted?
Yes, sir.
Yes. For n, which is not equals to -1, we're saying the integral of x to the power n dx, meaning integrating x to the power n with respect to x is equals to x to the power n plus 1 over n plus 1 plus c. Lerato. Where is Lerato? Lerato.
He skipped town.
Please. This is what Theo was just saying to you earlier.
But sir,
Okay.
there was no curve. That's why.
Sorry?
Like when I don't see that sign there, that
This
dx.
integral side. The integral
Yes.
side.
Yes,
But
I don't
that is-
integrate.
But when we are saying the antiderivative, you are the one who read that line there. Reverse of what?
No, sir, I thought like you say n times c and then n plus 1 instead of n minus 1.
No,
But then
Lerato.
it's fine now.
No. Now, Lerato, now it is no longer n minus 1. It is n plus 1 over n plus 1. Okay? Plus c.
Yes.
Is it clear? That's why I didn't respond to you yesterday. Remember, today we started on a bad note with you confusing the two. Yesterday, I didn't want to entertain that question of yours. The main reason being to avoid the confusion that you were at the beginning of this session, that you clarified. Now, here is my request to you. Okay. Do you see this table of integration formulas? Do you all see this?
Yes.
We're saying the derivative of the constant is 0. Then, on the other side, indefinite integral, the integral of a constant with respect, the integral of a constant with respect to x is the same as kx plus c. Are we together on that one?
Yes.
Yes. Next, we are all aware of the derivative of this. This, okay? Now, the integral of x to the power n with respect to n is x to the power n plus 1 over n plus 1 plus c. I hope you are still remembering this. This is what we have been dealing with in the past few minutes. Now, look at this one. The derivative of ln x, we all agree that is 1 over x. But now, the integral of 1 over x dx is equals to what? Ln x plus c. Clear up to so far? Okay. Here is the table continues. I believe okay, you will talk. Let me just finish here. I believe that your textbook has got this table. The table that enables you to can be able to learn from it to say the integral of e to the power x dx, which we just spoken about it a few minutes ago, is to say is e to the power x plus c. The integral of a to the power x dx is equals to a to the power x over ln of a plus c. The integral of cos x dx is equals to sine x plus c. The integral of sine x dx is equals to minus cos x plus c. We just learned this from Homo a few minutes ago. Or was it Sharon or was it Homo? Sharon, Homo? Who was it?
It was me.
Who is it? Homo?
Yeah, sorry, it's Homo.
Yes, thank you. And then again, the integral of sec squared x dx is equals to 10x plus c. The integral of cosec x times cot x dx is equals to minus cosec x plus c. The integral of secant x tan x dx is equals to secant x plus c. The integral of cosec squared x dx is equals to minus cot x plus c. Then we come to these interesting ones, these last three interesting ones. The integral of 1 over the square root of 1 minus x squared is equals to sine to the negative 1 of x plus c. Then the integral of 1 over 1 plus x squared dx is equals to 10 to the negative 1 of x plus c, and the integral of 1 over x, the square root of x squared minus 1 dx is equals to secant to the power negative 1 of x c. My request is that learn these formulas. The reason my focus was on the right-hand side is because we just finished dealing with differentiation. So all these formulas on the left-hand side, you are already familiar with. Now we are moving from the left-hand side to the right-hand side. That is the journey that we're embarking on. Yes, someone's called me before while I was still trying to explain this table. Please go ahead.
Yes, sir. Oh, yeah, sir. Like what I wanted to ask is that, like when I'm writing my answer from it, the answer being a ln something something, like is it important that I put it in the parentheses or in the modulus instead? Because sometimes I can find that some answers are written in terms of modulus from the natural log. Sometimes they are written in terms of parentheses. So I don't get the point where I will be going wrong if I choose to do either of this.
The parentheses.
Yes, sir.
Yes.
So you say my answer is supposed to be the natural log of x squared plus 4. So does it have to be inside the modulus or inside just the parentheses?
Inside the parentheses, not the modulus.
Okay, sir.
Yes.
Sir.
Hello.
The integral of 1 all over negative square root of x squared is the inverse of cos x plus c.
Where are you, Rado?
Like you see those special ones, those ones that have inverses.
Yes.
So I wanted to know, you see the sign one there. When you're doing differentiation of inverse trig, You said negative. Inverse of cos, you add the negative in front of the square root. So I wanted to know there, when you add the negative, does it give you the inverse of cos still when you're integrating? Or you have to put the negative outside of the integrand and then you write the inverse of sine?
Lerato, you said I should focus on the last three. Now, which one on the last three from the bottom of the table should I look at?
Number 3.
Number 3 from the bottom.
Yes.
Okay, I'm looking at it. The integral of 1 over the square root of 1 minus x squared is equals to sine to the power negative 1 in sine to the negative 1 of x plus c. That is the integral of that.
Yes.
Your question? Yes.
When we're differentiating inverse tricks, you said the inverse of cos is equal to 1 all over negative square root of 1 minus x squared. So I wanted to know if
hang on. What did I say? I said the derivative of what?
Of inverse of cos x.
Hang on. Inverse of cos x.
Yes.
Inverse of cos x. Which one are you talking? Inverse of cos x. I don't see it here. Everything that I've spoken up is not on the table. I don't see
it. But it is negative 1. So if you were to derive the inverse of cos, it will be negative 1 over square root of 1 minus x squared.
So I'm asking, when we're integrating negative 1 all over square root of 1 minus x squared, do we put the negative outside and write inverse of sine? Or is that whole thing the inverse of cos now?
You can pull out that negative. You can pull out that negative, or if you can really identify that if it has a negative 1 over the square root of 1 minus x squared, then you will know that it's the same as the inverse of cos. So you'll just substitute the inverse of cos.
Plus c.
Did I answer your question?
Yes. That's what I wanted to know, whether we write the inverse of cos or we take the negative outside and then replace this with the inverse of sine. That's what I wanted to know.
Okay. Thank you. Lerado, remember from where we started with from the derivative, where we started with the first one. I think the first one that we started with was the derivative of sine. Yeah. Everything, all those formulas from there are your tools in your bag, including all these. To those, then you add these ones for integrals. Okay. You are not throwing anything out of this toolbox of ours. We are just adding. So now, the next thing that, oh, now I'm sitting in the dark. Let me switch on this cell phone. The next thing that we will be doing next will be to apply all these equations like we did with the application of those formulas that we learned while we were differentiating. Are we together?
Yes,
Hello?
sir. Yes.
Yes, sir.
Yes, sir. Yes, sir.
Thank you. I know this is too much, but unfortunately, this is what we just have to do. Okay, let me just talk to you over this example 3.9.2. Do you agree that the integral of open bracket, x plus e to the power x, close bracket dx, is equals to x to the power 2 over 2 plus e to the power x plus c.
Yes.
Yes, I agree.
You all agree?
Yes, sir.
Then, do you all agree that the integral of x, e to the power x dx, is equals to x, e to the power x minus e to the power x plus c?
Disagree.
Agree or disagree?
I disagree with the statement.
Why, Lerato?
No, sir, that's not how you integrate.
That's how it's not how we integrate.
Yes. Like there's a minus on that equation. And
Mhm.
original one, there's no minus. And also, like, you know, sir, this statement is wrong, man.
Lerato, I'm not convinced. Okay. This is what these people are saying. This is the derivative of x squared over 2 plus e to the power x plus c, which is equals to this. Now we integrate this. What is on the right-hand side? The integral of what is on the right-hand side is x to the power 2 over 2. The integral of e to the power x. Now we go back. What is the integral of e to the power x dx? Is e to the power x plus c. This is what they used. Do we agree or still disagree?
I agree. Sir. I think one other thing we could use to make it simple, you can break those two into two different integrands. So you can find the integral of x dx plus the integral of e to the x dx, then it will still come up to that.
Thank you, my brother. Thank you. Then we'll end up having this. So we agree in number A to say yes, the integral of open bracket x plus e to the power x close bracket dx is indeed x to the power 2 over 2 plus e to the power x plus c. We agree with that one. Lerato disagrees with number B. Now let's go to number B. Where is this number B? Is the integral of x e to the power x. We come here. The integral of x e to the power x dx, they are saying is equals to this. Okay. Note that we are verifying an indefinite integral for a product. The antiderivative x e to the power x e to the power x is minus, what is this? Is not a product of the antiderivative. Furthermore, the product of antiderivatives x to the power 2 e to the power x over 2 is not an antiderivative of x e to the power x, since the integral, since the derivative of x squared e to the power x over 2 is equals to x e to the power x plus x squared e to the power x over 2 is not equals to x e to the power x. In general, the product of antiderivatives is not an antiderivative of a product. Lerato?
But I don't understand why it says the statement is correct.
Sorry?
They are saying their statement above is correct, but
yes,
it's not correct.
This one is not correct. This one, do you still disagree?
I agree the one below is the correct one, not this one on top.
Okay, this one I agree with you. That is not what is up. Okay, let me close it. Okay. Do you now agree Let me take you here. Yeah, you see what I've highlighted?
Yes, I can see.
Do you agree with this? Do you agree? Or do you need time to work it out?
That's the derivative though, sir.
Yes, yes.
I agree. Derivative of a thing.
What about the, and then the integral?
So that is saying. Okay.
Let me come here.
But like, so what do you separate them?
I'm trying to understand. I'm trying to understand, my brother.
Sir, you will correct me if I'm wrong. Remember when we are dealing with the product rule and we are differentiating, we add. So since in this particular case, we have a sort of a product rule, but in integral form, you do the opposite. So the opposite of adding is subtraction.
Okay.
I'll apply my mind to that. Abdul, let me not agree or not disagree with what you are saying. Né?
I hear you, sir.
I'll revisit it again. And then now, what I'm interested in is, okay, let me give you 2 minutes, just 2 minutes to verify. Do you see this exercise 3.9.2?
Oh, sir.
Yes.
We are verifying. We are not integrating.
We are not integrating, we are verifying.
Oh, me, I was integrating. Maybe that's why.
Maralerato.
My job.
Don't overthink. Now, in 3.9.2, maybe we can go through it. What is happening here? This mouse. Maybe we can look at 3.9.2 together. Do we agree that the integral of x cos x dx is equals to x sine x plus cos x plus c?
I agree, sir.
The integral of x is 1. Then you multiply by that cos. That's why that cos x is, that's where that cos x is coming from. Then now we are going to look for the integral of cos x. Let's go up here. The integral of cos x, here it is sine x plus c. Do we agree?
Yes, sir.
Hello.
Yes, sir.
People, are you still with me? Are you lost?
No, we're still with you, sir.
Okay. Thank you.
I'm still with you.
We are using these integral formulas. Thank you. So the integral of x is 1. 1 times cos, that's where this cos x is coming from. Then the next thing, now we find the integral of cos, but now keeping x as x as it is. Then the integral of cos is then sine x. That's why we're having x sine x plus c. That's where it's coming from. Now, where should I go? I'm going to Okay, no. Please. Do you, I don't want to confuse people. Okay. Do you see example 3.9.3?
Yes, you see.
Please evaluate the integral of only number A, the integral of 5x cubed minus 7x squared plus 3x plus 4, close bracket, dx. I'm giving you 3 minutes. And then let me check. Kulufelo, are you here?
Yes.
Okay, then you will lead us in terms of sharing the answer with us. So you have got 3 minutes from now. Thanks.
The is done.
Thank you, Lerato.
Tool.
Thank you, Abdul.
I'm done.
Who are you?
Kulufelo.
Thank you, Theo. Thank you, Kulufelo.
Kanisila is done.
Thank you, Kanye.
Sharon is done.
Thank you, Sharon.
Makwana is done.
Thank you, Lavdelia.
Malosi is done as well.
Thank you, Malosi.
Ishmael done.
Thank you, Ishmael.
Erika is done.
Thank you, girl. Homo, where are you?
Homo is done. I was just about to say.
Okay. Spusiso, are you still here? Obvious, are you still here?
Busi says load shedding, so he left.
Oh. Oh, Sham. Okay. Spusiso, let me. Where is Spusiso? Okay, Spusiso left. Let me, oh, here. Yeah. Now Spusiso left. Obvious, is Obvious still with us? Obvious,
No,
are you still here? Huh?
No,
He left.
I don't think he's. Yes, sir.
Okay. Now let me update my list. Okay, Kulufelo, please tell us what you found.
I found 5 over 4 to x to the power of 4 minus 7 over 3 to x to the power of 3 plus 3 over 2 to x to the power of 2 plus 4x plus c.
Please repeat, everybody, please listen attentively.
5 over 4 to x to the power of 4 minus 7 over 3 to x to the power of 3 plus 3 over 2 to x to the power of 2 plus 4x plus c.
Who disagrees with Kulufelo? Please talk to them, Kulufelo.
Anyone who disagrees?
None of them. Okay. Now, number B. Kanye, are you ready?
Yes, sir.
Okay, please share your answer with us.
So I don't know if my answer is correct, but I got x squared plus 6x to the power of 2 over 3 plus c.
Hang on, Kanye. There is a background. Can I wait?
Should I repeat?
There is a background from where you are sitting. So I didn't hear what you said.
Sorry about that. So I said my answer is x squared plus 6x to the power of 2 over 3 plus c.
Please talk to them.
Who agrees or disagrees?
I disagree.
I disagree.
I disagree.
I disagree.
What did you get?
I got x squared over 2 plus 12 plus 12 cube root x plus c.
Disagree still.
Okay.
Now I agree with this answer that was just read now. With the 12x cubed.
Yeah, 12x, yeah.
I agree with
Yes. Me as well.
It's x
Okay.
squared over 2 plus 12. Okay.
Okay, hang on. Who just gave the answer that Abdul agrees to?
Sharon.
Sharon. Okay, please read it out again, Sharon.
I got x squared over 2 plus 12 cube root x plus c.
Abdul. Okay. Up to so far, Abdul agrees with you. Please talk to them to hear who else agrees with you.
Homo agrees.
Homo agrees.
Malos agrees as well.
Malos agrees.
Pomozo agrees.
Who?
Pomozo.
Pomozo, welcome. How are you?
I'm good, sir.
Were you with us earlier in the year, or is it the first time you join us?
It's not the first time, sir.
Is Pomozo, ne?
Yes.
Okay. Thank you. Welcome.
Okay.
Who else agrees with the answer that was just said?
Ishmael agrees.
Ishmael agrees. Kanye. Okay, let's help Kanye. Kanye.
Yes, sir.
Please talk to them. Okay. Let me put it in this way for it to be seen. Yes, someone is calling me.
I'm saying I don't agree with the Sharon answer, and it's like you have agreed on something there.
No, I didn't. I'm not agreeing with anyone. There are people who agreed to Sharon's answer. So if you are still disagreeing with them, you need to indicate to us so that we can give you a platform to share with us what you found. Okay.
Yes, I'm disagreeing.
Okay, thank you. You disagree. Please wait there. We're coming to you. Who else disagrees with Sharon's answer? Except Lerato? Okay, Lerato. Please, the stage is yours.
I got like x squared all over 2 plus 4 over 3 x to the power 1 over 3 plus c.
Where is it different from what Sharon has just found?
They multiplied 4 by 3. and I multiplied 4 by 1 over 3. I think that's what the difference is. Because they have 12 and I have 4 over 3.
Sharon?
The difference is there.
Yes, sir.
Sharon? May you please talk to Lerato about that difference that you just highlighted?
Oh,
Can I ask a
okay.
question? X all over 1 over 3 is the same as 3x.
What?
Like the denominator is supposed to be x all over 1 over 3 all over 1 over 3 times 4.
Oh, I'm confused.
Integrate
Because
4x to the power negative 2 all over 3. You are supposed to get 4 on the outside times x to the power 1 over 3 all over 1 over 3.
okay, let me explain that part. I divided 4 with 1 over 3 for me to get 12.
You said 4 divided by 1 over 3.
Yes.
And I said 4 times 1 over 3. That's where the
Yeah.
difference.
Yes.
I'll go with the 12th one because we'll see the answer when it appears, I think. Yeah.
Okay.
Oh, Lerato, you are the only one who disagrees, ne? Okay. No problem. Now, please evaluate this integral, the integral of 4 all over 1 plus x squared dx. Integrate 4 all over 1 plus x squared dx.
Lerato is done.
Number C. Okay, now let me come here. Abdul?
Yes, sir.
Do you see number C?
Yes, sir.
I'll request you to lead us. Abdul, please lead us, brother.
Okay. So what I did, sir, I factored out that 4 on the numerator, which is also part of the integral loss. So I pulled out that 4 outside the integrand. And what I now have is 4, the integrand of 1 over 1 plus x squared dx. Then when you find the integrand of 1 over 1 plus x squared, you find it to be arctan x. And when you further simplify, the final answer will go as it being 4 multiplied by arctan of x plus c. That's my final answer.
Anyone who disagrees with Abdul?
So I wanted to ask a question because
please talk to Abdul then.
I did a mistake before. If it was 1 plus x, you're going 1 all over 1 plus x. You're going to say ln 1 plus x. But in this case, it's arctan, like inverse of tan.
Yes.
Okay, it's fine then.
Can I assume that everybody agrees with the answer that Abdul just shared with us?
Yes, sir.
Yes, sir.
Thank you, everybody. Thank you, Abdul. Now, Magwena.
Yes, sir.
Do you see number D?
Yes.
How many minutes are you giving us?
I'm not sure.
You are leading us.
Yeah, I know, but 4.
Okay, it's okay. 4 is okay.
The whim.
Sir, Makwena can what's this thing? She can, like, if you cannot see, write what's inside there on the side, and then you will see how to move forward.
So Lerato, are you saying this is the answer will be t squared or multiply by arctan t?
T squared, it's not a constant, so I didn't do that. It's not a constant in my case, so I did not do that. I integrated the same way I always integrate every single time.
Makwena. Hey, no. Are you okay?
I'm trying. I'm not okay.
Can I give you a hint?
Please.
So I'm gonna give you a bit of foreground, and then I'll give you the hint. So let's say I give you x, right?
Hmm?
And then what's the difference between x and x plus 1 minus 1?
Come again?
So if I say to you, what is the difference between x, okay, so the first variable is x, and then the
X,
second
yes.
variable is x plus 1 minus 1. What's the difference between them? Are they different?
No, they're not different.
Cool, so try this. You see the numerator, that is t squared.
Yes.
What do you think it changes if we say t squared plus 1 minus 1?
No.
Your job is done.
So think about it that way, because when we add 1 and we minus 1, we haven't, the sanctity of the thing is still the same, right?
Mm-hmm.
So here's my hint. Let the numerator be t squared plus 1 minus 1, and then split them into two integrals.
Thank
Oh.
you.
Think about it. So the one integral is going to be t squared plus 1 over whatever I have in the denominator. Then the other integral is going to be the negative 1 over 1 plus t squared, because I need the denominator still the same.
Mm.
So am I making sense? Does it suddenly look similar?
Yes, you are making sense.
Perfect. Do it. Do it in 3 minutes. You manage.
I just complicated the whole thing, G.
It's fine. You've got 3 minutes to redo it. So let your numerator be t squared plus 1 minus 1. And then leave the denominator the same. Split your fractions and integrate like you normally do. And you're going to be good.
Thank you, Theo.
Anytime.
Thank you, Theo.
Okay, I got the answer.
Okay.
Nice.
Have you got the answer?
Yes.
1 to 5
Okay.
now.
Please share it with us. Everybody, please listen. Please listen attentively. Makwena?
Yes, I got t minus arctan of t
So you're missing something?
plus c.
Thank you. Perfect. Thank you.
Agree.
Theo, sorry guys. Theo, do you mind sharing your solution, please?
Yeah. Give me 30 seconds.
Thank you.
I'm in class. My class
I shall share it.
Makwena, please repeat the answer.
My answer is t minus arctan of t plus c.
Also, say,
hello.
If it's negative arctan of t plus c, it's still the same.
Ishmael, I just posted it. It should show any second now.
Thanks, Theo. Yeah, I can see it now. Thank you.
Cool, man.
Please let me not respond, Lerato.
Why is Theo using these things? He's supposed to use the sum rule.
I don't know. Please talk to her.
The answer is the same, but it's supposed to use some rule plus in the middle.
Oh, my bad.
Okay. Okay. Do we all agree with Makwena's answer?
Yes, we agree.
All right.
Yes, we agree.
Number E. Now, Malos. Okay. Umuzo.
Lerato is done.
Yes, sir.
Pumozo,
Yes, sir. Yes, sir.
can you please lead us in number E?
On this case, ne, we should not forget those rules, like rules of adding fraction and what.
The rules of?
Like how to add fractions and what.
Everything that I've shared with you. Remember your toolbox. You just don't take anything from the toolbox. You take what you need to use.
So, say, here, formula sheet, there's no integration of a exponential function. Does that mean it will not show up in the exam?
Hang on. Okay. I'll be with you, Lorado. Magwena and Sharon. Lorado, I do believe that we have got an exhaustive table of integrals. So as we move along, this table will be expanding. Okay.
It's fine there.
We are not doing everything at once. We are doing these things piecemeal. Piecemeal.
Oh, piece by piece. I get it.
Pumozo and Malos will lead us.
Yes, I'm done myself, sir.
Hey, is it Malos?
Yes, sir.
Yes, then talk to Pumozo.
Okay, Pumuzo, what I did is that I changed my tan x into sin x over cos x.
Malos, hang on.
Yes.
You need
Yes,
to confirm.
sir.
You need to confirm with Pumuzo whether it's finished or not before you can start talking about what you did.
Okay,
Ask him
sir.
whether it's finished or not.
I'm done.
Then you can talk to him if it is not finished.
Okay, sir. Are you done, Pumuzo?
Yes, I'm done.
Okay.
What's your answer?
My answer minus cos x plus c.
Yes, the same as me.
All right.
Then talk to us.
Did everyone get the same answer?
Yes, I did.
Yes.
Yes.
Yeah.
Boss.
Yes.
Boss.
Oh. Okay, thank you, Malosi. Thank you, Pumuzo.
Yes, sir.
These are the answers to. This is the answer to number A. I think you all said you got this, eh? Yes. Abdul explained this. I don't want to spoil what Abdul said. So this is the answer for number A. Okay. And then for number B, this is what we got. Is this what you got?
Yes.
Yes, sir.
Okay. Now, number C. Is this what you got?
Yes, sir.
Thank you. Finally, this is what Pumuzo and Malose just found, yeah?
Yes, sir.
Now,
Sir, I the class name.
Magwena,
I'm leaving.
where are you going to?
I need to attend something now.
Hi. I also need to attend something now.
I'm coming. I'll be going.
Okay, it's okay. Then let me go away. This exercise.
Oh, sir.
Yeah.
Are you going to skip initial value problem?
Not really.
Okay.
Not really. Now, as a homework, please. I think we spend much time on this, eh? Do we agree?
This is the one above most.
So let me skip this. Let me skip this. Let me come here. Now, please take this one. Do you see number 1?
Yes, sir.
Please take it home. And then we'll start by checking it next time when we meet. Because I'm also sitting in the dark now.
Okay, so no problem.
Thank you, sir.
Yes, thank you, Theo. Now, before we call it a night, here is my request to you. Remember those question papers that you are in possession of?
Yes, sir.
I'm requesting you to do the following task for me. Please go to those question papers, put them alongside each other, print them out, put them alongside each other, okay? Look at question 1 on all of them, okay? Identify a pattern. Go to question number 2. Do the same up to where we are now on all those question papers. To can be able to tell the maximum marks that you can be able to accumulate in the exam, taking into account up to this point where we are. Am I making sense?
Sorry to interject, sir. I just want to know where can we find those question papers? I don't know if maybe they were shared before or.
Who's talking?
Sorry, it's Homo speaking.
Okay, Homo, I'll come back to you.
Okay, thanks.
Members, family.
No, so the thing is, I remember I sent to, I think it's Memdicate. I sent 12 question papers. So maybe she will send them or something, because me, I delete emails and stuff. And then
I hear you. Yeah, let me just interrupt you there. But before we go there, Lerato, remember
yes.
we shared a number of question papers with everybody, okay? My request to you is to say, take the fair order doesn't matter for me. Take them, put them alongside each other, print them out, put them alongside each other. Look at question 1 on all of them. Ask yourself, will I be able to get maximum marks in them? Not only by looking, but by attempting those questions. Because the reason I'm saying that, question 1 will be coming from the very same section. Question 1 of those question papers will be coming from the very same section. You go to question 2, you do the same. You go to question 3, just like that, in that order.
Sir.
Hang on, do you understand what I'm requesting you to do?
Yes, sir.
Do you all understand what I'm requesting you to do?
Yes, sir.
Yes, sir. Yes, sir.
Thank you. Thank you. Lerato, now you can come in.
Saying I understand what you're doing. The papers, I send them to Memdi Kelly. And on my case, I already know the pattern, but it's fine.
So that's all that I'm requesting you to do. So that when you go to the exam, you will already be knowing what to expect in question 1, what to expect in question 2. They won't change. The questions will change, but the pattern will never change. Do you get what I mean?
Yes, sir.
If you are dealing, if question 1 deals with limits, that will never change. Question 1 will be based on limits. That is what I mean. If question 3 is based, or question 2 is based on derivatives, or 4, throughout all those question papers to be based on that section.
Yes, and sir, they like to bring Swiss theorem in some papers as like, they don't bring it every time, but I'm just saying, question 2 or 3, they like to bring, they will like specifically say, solve this limit using Swiss theorem. Is they like to bring it. Yeah, that's what I'm talking.
We dealt with the squeeze theorem at the beginning of the year, remember?
Around March there, somewhere there.
Yes. So that is the pattern that I'm asking you to go and check on all those questions. Then from there, when we meet, then you will be able to tell me whether you will be able to make it in the exam or not. That's why I'm requesting you to do that. Then I will expect all of you, when we meet, to share with me, and then the observation from those question papers, as well as how you think you'll be able to perform in the exam. Taking into account up to this point, I'm referring to up to this point. Okay.
Yes, sir.
Thank you. Can we then call it a night?